In this video, I'll show you how to solve the ALEKS problem called predicting the formula of binary ionic compounds. This problem is going to give you the symbol and charge of two positively charged ions, cations, and then also two negatively charged ions, anions. And it wants you to write the formula for 4 compounds that you could form from these ions. Now, in theory, any positively charged ion could be combined with any negatively charged ion. So our possible combinations here would be each cation, each positively charged ion, with each negatively charged ion. So one of my combinations is the magnesium ion with the bromide ion. Another combination is going to be the magnesium ion with the sulfide ion. And that's everything I can do with the magnesium ion. And then I have another combination, possible combination, the nickel 4+ ion combined with the bromide ion, and the nickel 4+ ion with the sulfide ion. So this is every possibility that I have for these 4 different sets of ions. So when I'm coming up with the formula for an ionic compound, one of the tricks that I know is that the magnitude of the charge of the cation, in this case the 2, is the quantity of the anions that I need. And also the magnitude of the charge of the anion, which is a 1 for bromine, that is the quantity of the cations I need. So since my bromine has a magnitude of 1 charge, that tells me that I only need 1 magnesium. Since my magnesium has a magnitude of 2 charge, that tells me that I need 2 bromines or bromides. The quantity of each ion is in the formula, the quantity of each ion is written immediately after the elemental symbol. So this 2 here means that we need 2 bromides. It is honestly just as easy as that. Well, maybe not quite that easy because sometimes we have to simplify this formula down, but not for this problem. Or not for that particular compound. So one of my possible compounds is MgBr2. Let's take a look at our next example using that same rule again. The quantity of magnesium is the number of sulfide that I need. The quantity of sulfide is the number of magnesium I need. My magnesium quantity is 2. My sulfide quantity is 2. Now here's a situation where we do have to think a little bit more about the formula of this compound. Ionic compounds formulas are always expressed in the smallest possible ratio of numbers. So if we come up with a formula that has a ratio of 2 to 2, we should simplify that ratio as much as possible, which we can simplify that ratio down to just a 1-to-1 ratio. So this we're going to simplify down to just MgS, and that is the formula for our second compound. Now, this simplification process, we'll practice it again. You'll get another chance to see how it works. We didn't need to use it in this first example. In the first example, the ratio of ions was 1 to 2, and there isn't anything simpler than that. If either of these numbers is a 1, then the formula is as simple as it could possibly be. Let's take a look at our next example. Here we have a nickel 4+. That 4 is the quantity of bromide ion. The 1, that's the quantity of the nickel ion. So we need 1 nickel and we need 4 bromides. Our ratio is 1 to 4, and we can't simplify it any more than that. NiBr4. And then last but not least, here's our last example. The 4 is going to be the quantity of sulfide that we need. The 2 is going to be the quantity of nickel that we need. That's Ni2S4. That ratio is 2 to 4. Can we simplify that ratio? Can we make can we have that same ratio with smaller numbers? If this concept of simplifying the ratio is confusing to you, think about it like a fraction, 2/4. Or you could even do 4/2. It doesn't really matter. Can you simplify that fraction? We can. We could divide both the numerator and the denominator by 2. We could simplify that fraction to a 1 to 2 ratio. We could simplify 2 to 4 to a 1 to 2 ratio. We can simplify this compound down to NiS2. And that is our 4th compound.